Okay. An empirical formula is a chemical formula for a particular compound. Okay? There's two types of formulas we're going to look at. One's called an empirical formula. And when you look at the definition, empirical formula represents the simplest whole number ratio between the atoms that are bonded together. So most everything that you see a formula for in here, probably 90% of them are considered empirical formulas because you can't break the formula down into a simpler ratio. For example, H2O is an empirical formula. Okay? If you cannot make that simpler ratio than a 2-to-1 ratio. Okay? CaI2. You cannot make that any simpler than what we already have. Okay, so what we can solve for today, be able to solve for when doing these problems, are called empirical formulas. We cannot solve for a molecular formula with the information that you're going to be given today. Okay? Now, something that's not an empirical formula would be glucose. That is not an empirical formula. Now, what is the empirical formula for glucose?
H2O.
Right? CH2O. This is what we call a molecular formula. We'll talk about it more tomorrow. This is a molecular formula that's the empirical formula for it. Okay, here's another one that's not a molecular formula. Hydrogen peroxide is H2O2. So what's the empirical formula for that?
HO.
Okay, when we solve for problems that would be where we solve for the empirical formula of glucose, we'll come up with a ratio of CH2O. When we solve for the empirical formula for H2O2, when we're given information to do that, we're going to come up with the formula HO. Okay, questions you guys have? A lot of these that will be molecular formulas are actually molecules that are longer chains. You got longer chains of carbons. Okay? When you have longer chains of carbons, that's what happens. So we don't do much organic chemistry in here. But one really good example is glucose. That molecular formula for glucose is a simpler ratio of CH2O. Okay? So the question is, how do we find an empirical formula? So we're going to find an empirical formula, and we're going to basically do backwards of what we did for CO2. So you guys already have this written down, right? Don't write this down, but we said if you had one carbon, you have two oxygens. We multiplied it, 12.01. We got 12.01. Multiplied by 16 equals 32. We got 44.01 grams. And then we took each one of these and divided by the total, right? Yeah. To get the percent, times 100. And we came out with two percentages. Okay, and this top one was what?
27.3.
And then this was 72.7. Okay. Now we're going to reverse the process. So we already know the answer. The answer for my empirical formula for these percentages, when I use them, what's the formula of these percentages going to be? So if I work backwards, going back that way, what's the formula I should end up with the combination of C and O? CO2, right? 2 carbons, 1 carbon, 2 oxygens. We work the direction here, we find a percent. We can take the percents and go backwards. That's a lot. It's a lot more powerful to be able to take percentages based upon like a lab or some information you get in the lab and then find the actual formula for it. It's not that powerful finding the percent by mass. It's more powerful taking these percentages and going backwards and finding the actual formula. Okay?
How would you go backwards if you wouldn't have 44.01?
I'll show you. Okay? So, what we're going to do, we're going to take those percentages and the first thing we're going to do is we're going to realize this adds up to 100%. Alright, so 100% of its mass made up of both carbon and oxygen. That's the only thing in there. So it's 100% of its weight. So what I can do is if I write 100 grams down here of this compound, how many grams are oxygen? 72.7 grams. And if that's the case, then this would be 27.3 grams of carbon. So what we're doing, we're saying every sample we have percentages of, we're going to say, we're going to base it off a 100-gram sample. And since we base it off a 100-gram sample, we know how many grams we have of each one. It would be the same as the percentages. So basically, we just get rid of the percent. And we write in grams.
Is that it? Or is there more?
Well, there's a couple. Yeah, there's a lot more.
Whoa.
Okay? So, the first step you do is change percents to grams. Now, if they're already in grams, do you change percent to grams?
No.
No. They're already in grams. So, if you get to a problem and it says so many grams of this and so many grams of this is in this compound, and they don't have to add up to 100 grams, they're just based upon a sample size, then you don't do the first step because the first step is only for ones that were percent. Second thing you do is you change grams to moles for each element. Okay? So you'll change grams to moles for each element. So you guys can do that right now. Okay? So take a minute and change these grams up here, of carbon, into moles of carbon, and take the grams of oxygen and change it into moles of oxygen. Okay? So that should take you about 1.5 minutes or 2 minutes, no more than that. You guys don't need your periodic table for this one, do you?
Yeah. No.
Carbon, you know what it is?
0.011.
Okay. What about oxygen?
60.
Okay, there you go.
Is it 12.01 or 12.00?
12.01.
Isn't there 2 oxygens? Or does that not matter?
You don't know that. You don't know that. Yeah. And you know, based upon what we did with the percentages, it should be. Got to change in the moles.
Oh,
Yes.
my bad.
You wrote down both the numbers.
Oh, so,
Hey, can I borrow a calculator?
hang on.
Wait, what's this? It's 24 44%?
You bet.
No, what is that false?
Yep.
Okay. I didn't know.
Alright, I guess I'll make
If you're going to state softball, I would like you to take the test on Tuesday. The rest of them are taking it on Thursday. You'll get the review tomorrow. We'll be through everything tomorrow. Okay? And so you can spend the weekend or whatever you can, whatever time you have. I can go through the review with those people on Monday that will be going to state. And then Tuesday in class you can take it. So you don't even have to be in class on Tuesday and you can take it. Right? And hopefully those people that are going to cheer them on will do that too. That will study over the weekend. That way you don't have to worry about make up a lot of stuff when you come back. Because I remember always going to state softball, you used to miss 3 days. Now you only miss 2. You used to miss Wednesday, well, if you kept winning. You miss Wednesday, Thursday, Friday. So that was a lot to make up. So you guys will be ready for it if you take the time and go through the video, study it, and check your answers out on it. Because we only have one added type of problem we're going to do tomorrow, and we're done with the chapter. So that gives you the weekend and then Monday to prepare for it. You didn't know when you learned railroad tracks that you were going to use it so much, did you? And that process of being able to convert is so much more in here than just doing that idea.
I don't think I did this bad. Here you go.
Well, it's not going to come out really pretty on this one, Simon.
Oh,
wow.
It's not going to come out really pretty on this one. That's why I said, you guys, this is a higher order one right now because you don't know what step 4 is, but I want you to predict what you think the formula would be.
But I think I got it's like there has to be 2 phosphorus and 1 of this other zinc. Or I mean 2 phosphorus and 3. I mean take 3. 2 phosphorus, 3 zinc.
It comes out as 1.5.
I know.
You can do that.
I know.
Way around something.
We might as well not even deal with compounds like that. Just throw them,
Let's do it.
just throw them out. We don't care. We can't do it. Just we won't worry about them.
So then do we just assume that it's 2 phosphorus? Or 2 zinc?
Yeah, you should have rounded it. I got exactly what Garland.
Okay. So we're done with step 2. Again, here's a pitfall students have. This, I don't know how many, like a class of 24, I'll probably have 2 or 3 people that will not take this extra step and would round both of them. So then they'd say the formula is Z and P. Because they say, well, we're just going to round 1.16 to 1 and 0.77 to 1. And that's my formula. Divide by the smallest first. Okay, when you do that, okay, you're going to get these numbers you can't round. So the first one, you're going to get 1.5 moles of zinc. And the second one, you're going to end up with 1 mole of phosphorus. Okay, use common sense and realize compounds can only go together in whole number ratios. The ratio I come up with is 1.5 to 1. So the formula will be what? P,
P, just P?
nope.
What?
So 1.5 to 1 is what kind of whole number is bigger than a whole number? Be the same ratio, but higher. Yeah.
2 phosphorus, 3 zinc.
So be 2 phosphorus,
Oh.
3 zinc.
Oh.
Oh.
Oh. Everybody, oh.
Okay, so I'm going to give you a step 4. If you don't understand, you can't make that connection. So 1.5 to 1 is the same as 3 to 2, which is the same as 6 to 4, which is the same as 9 to 6. But it has to be the smallest whole number ratio. 6 to 4 would not be a good answer. Saying P6, Z and 4, that would not, or P4, Z and 6, that would not be. Okay? So what you do,
And if you add 1 and 1.
if you can't figure that out and can't see that, which is fine, after you do a couple, you will. What you do in step 4 is you multiply to get whole numbers. So multiply by a whole number to get whole numbers.
Does it matter which element you list first?
Yeah, not on this one because you guys don't have enough information on that. So, what am I going to multiply this by to get a whole number?
2.
2. So I get 3 zincs. Well, this one, and this is another common pitfall, students will do this and then they'll say their answer Z, 3, P. Well, if you have to do it to one, you got to do it to both. So, okay, so you got 2 phosphorus for every 3 zincs. So you can say P2, ZN3, or you can say ZN3, P2. It doesn't matter. Okay, either one's fine. Okay, so your assignment's on the board.
So,
Okay.
how do we know what to multiply?
You just have to multiply it by a number so it comes out even. Or comes out to be a whole number.
So that could be in any range.
You start out simple. Okay, Raquel, you just don't go pick out anything high number. You pick out, well, the first one I'm going to do is 2. Comes out. Well, that one didn't work. I'm going to go ahead and multiply by 3. Then I'm going to go 4.
Multiply them both by the same.
Yes.
Okay, so like
Yep.
any number that would get you that answer.
Hey, Dave.
Okay, so your answer, or your assignment is page 212. It's 43C, 44D, and 46D. Add that to your percent. Okay? Write that down because I'm going to switch slides here in a second.
Can we add that on to yesterday's assignment?
Add that so you'll have 6 problems, free from yesterday, free from today.
We turned yesterday's assignment.
No, you didn't.
Is your tomorrow?
Do tomorrow. It will be, but it won't be one you have to hand in. It'll be just one we'll practice. Yep. We'll just go off of the stuff that we did today, extend it a little bit, do a couple practice problems, and then have you, if you choose to work on them, choose to work on some problems, and then give out a review.
So will you like send me how to do it and stuff?
It'll be just like this. Yep. If it's this class, it'll be a loud video. If it's my 3rd hour, you won't hear anything. It'll be just silent.
The day before the last test we took, I watched all the videos.
Are you talking about this?
I want to have one little kids maybe like
I watched all the videos to make sure I understand.
Okay, did you guys get those all written down?
Yeah.
Okay.
Carson Jr.
What? No, just make your piece of paper.
You added on to the assignment that we had yesterday, please.
Yeah.
How do you turn it? How do you
What's
turn
the
it
percent?
when you're running?
Cameron, how can you explain it? Okay, let's go. What's your math?
Ratio 7, 39, 8, 40, 39.